Okay, here's a question here, number one. It says, if it is known that the sum of 28 consecutive odd integers is a perfect cube, list the first and last of the smallest odd integers that satisfy the condition. Let's go to the whiteboard and try to figure this out. So what I would normally do over here is just, I know it's a sum of 28 consecutive odd integers. So I'm going to just start with saying I have an odd integer. So I'm going to say x is an odd integer. Okay, so what am I going to do over here? I'm going to start adding them together. So if x is an odd integer, what would the next odd integer be? Well, it goes up by 2. What's the next one going to be? It's going to go up by 2. So that means it's going to be 4 now. All right? So this is the first odd integer. This is the second odd integer. This is the third odd integer. Now again, I can keep writing this down, but I'm starting to realize I do want to get to the end, by the way. So I want to get to the end. And the end is going to be, well, it's going to be x plus. Now this is the tough part for me. I had to think about it. All right? So if you look at the second integer, this is, like you might say first, second, third. And this is going to be what? This is going to be it says 28, doesn't it? 28. All right? This is the 28th. All right? So I'm starting to look at it, and I see it has something to do with multiples of 2. All right, so put this over here, 2 times something. So the first has no 2's, the second has 1 2, the third has 2 2's. So what the 28th would have? It would have 27 2's. All right? Again, looking at the pattern, the first one has 0, 2's, the second has 1 2, the third has 2 2's, and the 28th would have 27 2's. All right, so I feel satisfied about that. Now what I'm going to do over here is I'm starting to realize that they said something. I may not be able to remember what's been said, but I want to get my eraser out. I think that sequence is okay, by the way. Now what happens if some students are looking at this and wondering how many x's are there? First, second, third, it's up to the 28th. So I know there's going to be 28 x's here. I'll write this down now. So there's going to be 28 of them. Let me get my eraser out, different pen. There's going to be 28 x's over here. Now the next thing I'm looking at is a sum. And the sum I'm looking at, I'm kind of looking at it, I'm going to make sure I got this right, by the way. It's going to be 2 plus 4, and they're going up by 2, by the way, 6 plus 8, and yada, 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 all the way up to 2 times 27. All right? Now I'm going to factor out a 2. And that's going to be 2. And that's going to be 1 plus 2 plus 3 plus 4 plus up to 27. I know how to sum the integers from 1 to n. And that's a formula that you should be aware of. It's going to be 2. And then it's going to be, n, which is 27, n plus 1, which is 28 over 2. That's just complicated, doesn't it? Let's keep writing this down now. It's 28x plus the 2's cancel, and I get 27 times 28. Again, I'm kind of thinking this, I can't remember what they said about this, but I'll just factor it out. That's going to be 28, and then you can get x plus 27. All right? Now, what did they say? It is known that the sum of 28 consecutive odd integers, I just did that, is a perfect cube. So this thing over here is a perfect cube. All right, let's think about that now. So 28 is going to be 4 times 7, and then x plus 27. Again, it's perfect cube. Then I'm looking at this thing over here, and how could I make that a perfect cube? I'm starting to realize that I'm seeing part of it, but not fully. I mean, I got 2 squared, and then I got a 7. So over here, x plus 27, well, to make it a perfect cube, there's actually an infinite variety of things, but they said the smallest, right? The smallest. So the smallest thing I could do is I need another factor of 2, and I need another factor of 7 squared. And why would that? I want this to be 2 cubed, times 7 cubed. And that's going to be a perfect cube, by the way. So let's figure this out. So x plus 27 is going to be equal to 2. 7 squared is going to be 49. So x will equal, let's see, 2 times 49 is 98, minus 27. Well, let's hope this is odd, right? And let's see, 98 minus 27 is going to be 71. Certainly an odd integer. So now I know what the odd integer is. It's 71. So if you thought about it now, you get 71 plus, what's the next odd integer going to be? 73 plus, I think you get the idea. Now, I want to get to the last one, and we'll get to that question in a moment, by the way. Let's go back up here. And what's the last one going to be? It's going to be this one over here. And what's that going to be? Dot, dot, dot. It's going to be 71, which is x, plus, let's go back over here again, 2 times 27. Well, 2 times 27 is going to be 54. And this is the last one. What do you get over here? Well, this is the first one. And this is the last one. What's the last one going to be? Let's take a look at that. 71 and 54. Let's write this down. I don't want to make a mistake, right? That's going to be 5. And that's going to be 125. All right? What's their question? Again, I'll read it back to you. List the first and last of the smallest integers. So it's going to be 71. They want me to list it, and 125. Put a box on it, and it's done. Thank you.